Let's talk about strengths and weaknesses of data visualization. You might have seen a misleading graph before. So take a look at this one. What seems misleading? Well, we have a difference in what the numbers are suggesting versus the picture. Looking at the difference in the numbers, it's 29% of people in this survey said yes, they're in favor of increased pandemic-related restrictions. 1 percentage point more, 30% said no. So small difference, it seems like. But then with this picture, it looks like that's quite a sizable difference. So we kind of get a different impression from the numbers as from the picture. And what you might be feeling here is manipulated by the maker of the visualization. It's possible this was an accident, but at least for me, it makes me wonder, are they trying to get a certain emotion out of me with this picture? Now, some graphs are misleading mostly by accident. This is one I'm pretty sure is an accident. First, to set the stage, we have two K-pop bands, Weekly and Red Velvet, and a fan on the internet decided to make a graph of the average height of different members of various K-pop band. So Weekly, it looks like, has an average height. They're the tallest on average. I guess they took the heights of all the individual members, they averaged them, and that came out to about 5'6". And Red Velvet is an average of about 5'3". So that's a fairly small difference. But looking at this picture, it seems that the members of Weekly would simply tower over the members of Red Velvet. It looks like they're just completely different scales. And I think what's happening here is that the visual just isn't working as the designer had hoped. So the perception of, these different icons creates an impression of just a much larger difference than there really is. So here we can see that if we draw these dashed lines to say, okay, so what's the heights of, Weekly and Red Velvet? Wow, that looks like a huge difference. Now, in fact, the real difference in the heights, if we had, tried to graph it more realistically, is actually very subtle. The average difference in their heights is quite, it's only a matter of about 3 inches, that the average height of a Weekly member is about 5'6", and the average height of a Red Velvet member is 5'3". And choosing different iconography, we could maybe make a more accurate depiction of the magnitude of that difference. Here's another example. So this is some data from a vote, I believe, in Ireland. I just found this on the internet and thought it was interesting. And it looks like the designer of the graph thought it would be cool to introduce a three-dimensional element so that the height of these cylinders would tell us how much of the vote had gone in favor of yes or no. But unfortunately, it's very hard to discern the differences in the height of these cylinders the way this is visually presented. And so it looks like there's barely any difference, at least to me that's how it looks, when in fact there's 99.1% of people voted yes and less than 1% voted no. So a quite dramatic difference, but that difference is really hard to detect. Now, some graphs are just plain confusing. This is one I found exploring UNICEF, which has data about countries all over the world, and it looks like the data is about various investments that they have and some kind of supply. But to me, this is simply overwhelming. I'm not sure what to look at. I'm not sure how to read it. So very confusing to me. So why does this happen? It might help to remember why we visualize data in the first place. So a quick question, which would you rather have? If you wanted to understand something about flight delays at New York City airports, something that you might remember from earlier videos, would you rather have this chart depicting, the frequency of various flight delays? Or would you rather have a table of the raw data, just over 300,000 rows of flight delays? Probably you'd rather have the picture. And that's because data visualization helps us efficiently communicate a pattern in a data. Now, every visualization has a couple of ingredients which are more or less in our control. Those are the data, so what actually is there that we have to visualize, the choices of the creator. So if you're the creator, you have some control over this. And there's also the viewer's perception, which can be a bit more unpredictable. Now, data visualization creators might have some competing values. So they might have a couple of values in mind that are not necessarily possible to achieve at the same time. So on the one hand, if we think of this as like a tug of war, on the one hand, they might want to expose the data so viewers can explore it for themselves. On the other hand, they want to tell a story efficiently. They know that their viewers only have limited time and attention, and so it's important to get across, the big ideas from the data. So on the side of exposing data so viewers can explore it for themselves, here's a chart that I think, at least to me, this took this to an extreme. So this is a chart that I found in a McKinsey report, and this is about industries that are affected by COVID-19 and whether or not those industries are disproportionately women or disproportionate men. So this chart, because it's an area of data and research that I'm not really familiar with, and this exposes a lot of aspects of the data, I personally found this one a bit overwhelming and hard to understand. But perhaps if you're somebody who's more comfortable with this, type of data, then this is easier for you to read. But for me, I felt a bit, overwhelmed by how much there was to explore here. On the other hand, you can go to the other extreme of telling a story efficiently, but where you really hide everything about the data behind it. So this is an image from a YouTube video about why is modern art so bad. So obviously it has a very strong opinion to share. And so it's trying to argue that something called standards have declined over time, but it's not clear what standards are or how they were measured. It's not clear where this blue line comes from. I don't know if it's an actual measurement from a person or if somebody just made this up. So I have no idea where any of this data is from. So they are telling a story efficiently, but I cannot explore any of what's behind this for myself. So data visualization choices have consequences for what a viewer is able to discern, and that means they could either expose or hide relevant patterns. Here's one more example. This is from a Pew Research Center report about home births in the US. So this is data about in the United States, some people choose to have, if they're pregnant and they're gonna give birth, they can do it in a hospital or they might do it at home. So in this bar graph, we can see that it looks like in 2020, there were more home births indicated by a higher green bar. And we have a kind of companion chart, this gold line chart. And in this one, we can see that it looks like there is an uptick in the percentage. And real quick, just think for a minute, why are both of these charts important to be shown together? Well, one reason I think this is important is because of if we only see the raw number of births, which is this green bar chart, it's possible that what if in 2020 we just learned that there had been more births overall? Then there would have been more home births, but not necessarily a higher percentage of births would have been home births if there was a corresponding increase in the overall number of births. So to discern if something is getting more popular as a percent of births, we need to have it represented as this percentage, which is in the line chart. So these two charts are complementary, and I think they're both important to understand the magnitude of the trend. Now, from those charts, you get a very high-level picture. But we need a different chart to appreciate that not all families are equally likely to choose a home birth. So in a chart later in the report, we can see a breakdown of that data by race and ethnicity of the women who participated in the survey, as well as their education levels. And from these charts, we can see that the decision to have a home birth is not equally occurring across all races and ethnicities. It's more likely in white women, and also not by, across all levels of education. It seems to be more common among women with less than a high school diploma. So in these different charts, the creator is emphasizing different aspects of the data. On the one hand, we can see that home births are getting more popular in the US, but we need this other chart to appreciate that this choice isn't equally popular across all racial and ethnic groups. It's not happening the same everywhere. And what stories you see also depends on who you are. You're going to approach this chart differently and potentially take a different message away if you are somebody who is deciding, do I want to have a home birth? If you are a health educator in your community, if you are a nurse or a doctor, or if you're somebody who works in public health and policy. You might come away, you might think of different things as you see this chart, depending on what lens you bring in the first place. Now, data visualization is a huge topic, and we've just begun to scratch the surface. What I would like you to take away from this very, very crash course in, one big theme in data visualization is that visualizations are the product of many choices by their author, and every choice has trade-offs. Some aspects of the data are going to be hidden and others are going to be emphasized. There is simply no avoiding that. So remember this when you're looking at a chart, and you can think, what choices did the author make? And because of those choices, what did they emphasize and what might they have obscured?